This video is on Vesper Theory, also known as molecular geometry. Vesper is valence shell electron pair repulsion. So this means that in the valence shell of our atom, the electron pairs are going to repel each other. And this causes a molecular geometry to occur, or the shape of the molecule is going to change based on the pairs of electrons. So 3 things to know about Vesper theory. First, the shape of a molecule is 3-dimensional. It's based on the location of electrons, specifically electrons in lone pairs and in bonds around the central atom. These electrons repel each other due to their negative charge. Lone pairs take up more space than electrons do in a bond. Remember, a lone pair on our central atom are 2 dots on that central atom, where a bond is our central atom bonded to another atom. So in this bond, I picture 1 electron on either side of my bond. For here, my electrons are side by side. When they're side by side, they take up a large area of space. They have this big electron repulsion field. If they're on a bond, you can think of it being like a basketball passed back and forth between the 2. They don't take up as much space in different directions. The shape of a molecule is going to minimize the repulsion of shared and unshared electron pairs. Shared being electrons in a bond, unshared being lone pairs of electrons. So 2 examples. Here I have CH4, which we would classically drop the carbon in the middle and the 4 hydrogens coming out on either side. If I look here, I don't have any lone pairs on my central atom, but on my central atom of carbon I have 4 bonded atoms. So my number of bonded atoms is 4. My number of lone pairs is 0. Remember that this is in 3D space, so 360 degrees around on all directions. So in reality, my carbon atom, which I've first drawn like this with my carbon and my 4 hydrogens coming out, well really it looks like this, where I have 3 of them pointing down, the 3 hydrogens point down, and 1 points up. So they kind of make a tripod that comes up to the top. But notice that this has 4 faces. 1, 2, 3, and then my face on the bottom makes 4. Okay. This is called a tetrahedral. On the second page, or the page after this in your notes, you have a chart. Your chart probably looks similar to this. If it doesn't, you'll get one in class tomorrow. If we look on our chart, I have 4 bonded atoms to the center atom. I have 0 lone pairs. That gives me the shape of a tetrahedral. So I have these 4 faces to my molecule. My second one that I'm looking at is water. Here I have lone pairs. We typically draw it where we have oxygen in the middle and a hydrogen coming out to one side and the other side with our 2 lone pairs on our central atom. Remember that lone pairs take up a lot of space. So my electrons take up all the space here and here, and they force these electrons in the bonds to the hydrogens to move closer together. So these hydrogen bonded to the oxygens here move closer together while the oxygens push them down. And so instead of it looking straight across, my electrons, which are my white things here and here, these clouds of electrons push down on these hydrogens to force them closer together. So what I have is a bent molecule, as opposed to it being linear, just straight. So I have my bonded atoms is 2, 1 here and 1 here. So 2 bonded atoms. I have a pair of electrons here and a pair of electrons here on my central atom. So 2 pairs. So I look at my chart. Bonded to the central atom is 2. Pairs on the central atom is 2. So it gives me a bent shape, where 1 here and here, and it's bent. It can also be bent with 1 lone pair to the central atom. So this is a bent molecule. So after we draw our Lewis structures, we'll count bonded atoms, lone pairs, and that'll tell us our shape. One more part to this is polarity. If something has a polarity, it can either be polar or it can be nonpolar. Polar is an unequal distribution of electrons. And it also has to do with their electronegativities. Nonpolar is an equal distribution of electrons. We abbreviate polar as P and nonpolar as NP. Something that is polar is going to have electron pairs or lone pairs on the central atom. A nonpolar compound will have no lone pairs on the central atom. Something that is polar is going to be asymmetric, and something that is nonpolar, the equal distribution, is going to be symmetric. So if we look at our two examples, CH4 is symmetric and has no lone pairs on my central atom. So CH4 is nonpolar. My H2O, I have lone pairs on the central atom. So that means that I have more electrons here than on the outside. And that means pairs on the central atom is polar. So water is a polar molecule.